Hello? Hello, can you hear me?
Yes.
All right. Tonight, I want to show you where we focus on. Last week, we finished the probability theory. Data description. So we're going into a new topic, which is probability. Now, let me show you what we're covering this week or tonight. It's week 6. Just 1 minute. Let me check this names. 1 and 6. All right. Smith. I'm taking your attendance. Let me take down the names of few people that just joined. Oh, that's it. Okay. Now, we'll be looking at chapter 4. Well, that's what we'll be focused on this week and the coming weeks. And this week we have 2 assignments due that will be due, which will be classwork 6 and homework 5 due this week. Okay. Now let's begin. I close. I opened too many pages, so let me close some of them. All right. Tonight I will be focusing on this topic: probability. Probability. This week and the coming 2 weeks, that's what we'll be doing. It's a large topic, probability. What is probability anyway? When we say that, when we say probability, we are referring to the likelihood of an event occurring or happening. So, in a simple way, it means how likely it is that some event will happen. That's what we call probability. So an event with a probability of 1, then if you say that an event has a probability of 1, it means that the event is a certainty, because 1 means 100%. So when we say probability of 1, that means we are 100% sure that the event will happen. Okay. Now, for the if the event has a probability of 0, that means it won't happen. So we are sure that it won't happen. So we say that it has a probability of 0. Now, this is how we write probability. Let's say that probability is the chance of the event happen is 7 out of 10. So we can write it as a fraction. 7 over 10. Okay. Or we can write it as a ratio, 7 to 10, or as a percent, 70%. So this is different ways of writing the probability of an event occurring. We can also write it as a decimal 0.7, which means 70% or 7 over 10. They all mean the same thing, depending on what the question says. At this point, we are ready to look at some of the basic concepts of probability. The first one we look at is a concept that we called probability experiment. A probability experiment refers to the chance process that lead to a defined result that we call outcomes. Any chance process that leads to a well-defined result is a probability experiment. That result, we call it outcomes. For example, if you flip a coin, the coin can land either as a head or a tail. So flipping a coin is a type of probability experiment. As a matter of fact, many examples we meet in this topic, we involve gambling, because it is the gamblers actually started using probability until eventually it was realized that this can be applied to other aspect of life, in education, in science, in business, and so on and so forth. So many examples we do involve gambling. We roll a dice. Of course, you know what a dice is. It's a dice. We roll a dice, this moment. Then you know that the probability of any of the outcome in the dice. A dice can normally dice have 6 sides. The probability of any of the sides showing up. Or we're not doing that now, but that act of rolling a dice is a probability experiment. Which means any side can show up. 1 can show up, or 2 can show up, 3 can show up, 4, 5, 6. And this is it. So this is what we call probability experiment. Any chance process that lead to a defined result that we call outcomes. Buying a lottery ticket is a probability experiment as well, because the outcome can be either you win or you lose. Okay. When you draw a card from a deck, it's also a probability experiment. The outcome can be, let me show you how the outcomes in the card would look like. To look like this, I think I have it somewhere. See the card. See all the possible outcomes. It can be a club, it can be a diamond, it can be a heart, or it can be a spade. Club, let me write this down. It can be a club that you chose. It can be diamond. It can be hearts. It can be spades. So under this, the probability experiment now becomes selecting a card from a deck of cards. So that's the experiment. And the outcome can be that you selected a club, or you selected a spade, or that you selected the heart. You selected any of the suits in the card, then diamond. This can be the outcome. And each of them, I think each of them have 13 cards on it. So what are outcome? Outcome as the result of a single trial of a probability experiment. You look at this, flip the coin. The outcome is either it's a head or a tail. If you buy a lottery ticket, it's either you win or you lose. If you roll a dice, the outcome can be 1, 2, 3, 4, 5, or 6. So that's what outcome is. When you take an exam, outcome that either you pass or you fail. That's the outcome. Okay. Now, this leads us to the next concept that we call sample space. Sample space is the set of all the outcomes of a probability experiment. For example, I'll use this as an example. Probability experiment here is rolling a dice. Okay, I'm going to use 3. The outcome can be the sample space. All in a dice, the dice have 6 sides. So all the possible outcomes of a probability experiment, they will now become brown, AB, 1, 2, let me put a set, we enclose set in a brace bracket. 2, 3, 4, 5, 6. Okay. As the outcome. Okay. Just 1 minute. Let me write down this name. Angel Brown. Okay. Now, the days of the week, all the possible outcomes, the sample space would be, it can be Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. No, Saturday, Sunday. Okay. That is the sample space right there. Sample space there. Now, any question in what I have covered so far? Any question? Hello, class.
I have a question.
Yes, ma'am.
Where can we find the Word doc you're sharing right now?
Where you can find what again, ma'am?
The Word doc you're sharing. I didn't see it in the files in Canva.
I mean what you are seeing on the screen now?
Yes.
Oh, it's not in the file. After I'll upload it.
Okay. Thank you.
Yes, you're welcome. I'm gonna save everything we did and then upload it. Any other question? Please, if you want to ask a question, ask question. I don't do texting when I'm in a classroom. All right, let's look at this. Tree diagram is another concept. We use a tree diagram. It is a visual way of displaying the outcomes of a probability experiment. So we use branches, and I will show you how this works. Example, let's use this question. Let's use this as a question. The question says, find the sample space. Sorry, find the sample space for the gender of 3 children of a couple. So if a couple decide to have children, what is the possible gender of those 3 children? Excuse me. So we can get that by using the tree diagram. So it's a visual way of displaying all the outcomes in a probability experiment. So for this particular family, we have we can use B for boy and G for girl. I put the numbers in. The first child, this is the first child, might be a boy or a girl. Then for the second child and third child, you just draw a line, 2 lines that will represent boy or girl. So for this one, we have, you can use this as second child it can be either boy or a girl on this side. And on this side, it can also be either a boy or a girl. Okay. That's for the second child. Then for the third child, each of these outcomes, you draw boy and girl for each of them. This one gonna be for the third child, can be boy, girl, boy, girl, boy, yeah. Okay, boy. Okay, I'm gonna let me move this down a little bit so that we can have enough room. Because we don't have enough room here. move to the next section. A boy, and then the girl. This is for the third child. Remember, this couple want to have 3 children. So let's look at the outcome, all the possible outcomes. It can be the first child is a boy, second child is a boy, third child is a boy, which is BBB. That's B, B, and B. So it can be first child is a boy, second child is a boy, third child is a girl, BBG. First child is a boy, second child is a girl, third child is a boy, BGB. First child is a boy, second child is a girl, third child is a girl, BGG. So we repeat the same process for the on the girl side. Excuse me, I think I messed up something here. Okay, so we'll repeat the same process here. Girl, boy, and boy. Okay. Girl, boy, and boy. Girl, boy, and girl. Okay. Girl, boy, girl. Then girl, girl, boy. Okay. EGB. And it can be all girls, like we have before for all boys. So how about here? So what this side said gear? I think I click on something and it disorganized it. So boy, gear, and boy, gear, and boy, and it can be boy, gear, and gear, boy, gear. So this gives us a sample space. How many? I have 1, 2, 3, 4, 5, 6, 7, 8. So we give us this sample space. These are all the possible outcomes. If we see a family that have 3 kids, the gender will be fall within any of this group, must fall within any of this. So sample space is 8 possible outcomes, 8 outcomes, 8 possibilities. 8 possibilities, possible outcomes. Yep. So if you want to calculate the probability of boy and girl, we'll come back to that when I actually introduce the probability concept. Okay. So the sample space. Then next is events, another concept. Events simply mean a set of outcomes of a probability experiment. We have 2 types. We have the simple event and the compound event. Simple and compound event. Okay. Let's look at each of them one by one. A simple event is an event with only one outcome. We roll a dice. The outcome can be head. 6 showing up or 5 showing up. So these are compound simple event. Or it can be 2 showing up. Okay. For 1 dice. Or it can be 5. So 1 outcome. So you call it simple event. Now, in this case, we have roll a dice and get a 6. So only 1 outcome. You can see right here. Roll a dice and get a 2 can be only 1 outcome, 2. That's a simple event. Getting a Monday. We want to choose a day of the week, and you choose getting any day, Monday. So it's a simple event. Monday. Okay. Now, that explains it. For the compound event, we're looking at 2 or more events. 2 or more outcomes. For example, if you roll a dice and get an even number in a dice, we have 6 numbers in a dice. To get an even number means to get 2, 3, 4. 2, 4, and 6. And if you choose a day of the week, and to get a weekend means to get Saturday, comma, and Sunday. See? So the outcome is more than one. Okay? 2 or more outcomes give us a compound event. Okay? Now, another concept we'll be looking at is the probability of an event, impossible event. Event is impossible if it is not likely. It is if the probability is 0, that means it will not happen. It will not happen. For example, in a 6, getting a 7, when you throw a dice, 1 dice to get a 7 is impossible. Then there's one unlikely event. Unlikely event can occur. It's possible to occur, but it has a very slim chance, usually less than 50% chance of occurring. Okay. So when it's less than 50%, we say that it's an unlikely event, like the probability of getting a COVID-19. Some people got COVID-19. I mean, during the time when we had the pandemic, many people can get it. You can get it. It's possible. But many people didn't get it. So it's unlikely. But because it has a probability of 44%, that means it's possible to happen, but not always possible. Now, how about this? The chance, if the chance is greater than 50%, it is likely event, like 75%. Getting a job after graduation, 75% or 80% is, Now, at this point, we are ready to go to the way we approach probability, what I call types of probability. But before then, does anybody have a question so far?
No.
Okay, good. Now, the 3 types of probability, we have the classical probability, empirical probability, and the empirical probability, we can also call it the relative frequency probability, and then subjective. This one, we don't normally use it because it is subjective. The one we focus on is the classical and the empirical probability. Under the classical probability, we compute the probability of an event based on the known sample spaces. So that means we know the sample space already. For example, a dice of 6 sides, sample space is 6. So we use it to calculate the probability based on that sample space. Day of the week is 7. So we can calculate the probability of choosing a day of the week using that known sample space. Card, we have 52 cards in a deck. I think we have 52 cards. That's the sample space. So we know. So that the probability of choosing a king or queen, we can calculate it using this sample space. A coin have 2 sides. So you calculate the probability using that information, sample space. So under the classical, the number of probability of events, the formula becomes the probability of that event happening is number of ways event E can occur divided by the total number of outcomes in the sample space. That is for classical probability. For empirical probability, we use the, before I explain that, let me throw more light on classical. Classical, for example, day of the week, the probability of choosing any of this day, let's say choosing 2, will be 1 out of 6 chances. If it's a coin, the sample space is 2. So the probability of getting a head or, can be 1 out of 2 chances. And for a card, since we have 52 cards, the probability of choosing any of them, any card, is 1 out of 52, since we know the sample space. For the empirical probability, we don't know the sample space, so we have to calculate it by ourselves through observation. We observe the number of occurrences of the event through experiments, and then calculating the probability. We'll come to that probably later tonight. The subjective is, in this case, we rely on intuition or experience. Basically, we are making an educated guess. So which is mean that it's not reliable. For example, a doctor may say that on basis of his diagnosis, that there's a 40% chance that the patient will need a surgery. I've seen people who were told that, and eventually they found out that the person will not have surgery. I mean, sometimes they do, sometimes it doesn't have, it's not like the empirical or the classical one. So we're not going to go into subjective probability. So let's do some examples here, ask some questions. Say, find the sample space for rolling 2 dice. Rolling 2 dice. To define the sample space of rolling 2 dice, you know that the first die has 1, 2, 3, 4, 5, 6 sides. Second dice have 1, 2, 3, 4, 5, 6 sides. So the sample space can be in this form. We put it in a chart like this. We have 1, 2, 3, 4, 5, 6 for this die 2, and then for die 1, which we can see. Okay, dice 1. I don't know how to write it. Dice 1. Okay. Dice 1 might have this 1, 2, 3, 4, 5, 6. Okay. Now, so when you pick the card, it can be 1 and 1 showing on both dice. You can see 1, 1. Or it can be 1 and 2 showing on both dice, which is 1, 2. It can be 1 and 3, 1 showing on the first dice, and 3 showing on the second dice. That is 1, 3. 1 showing on the first dice, and 4 showing on the second dice. 1, 4. 1 or showing on the first dice, and 5 showing on the second dice. 1, 5. 1 showing on the first dice, and 6 showing on the second dice. 1, 6. So it can be any of these outcomes. It can be 2 showing on dice 1, and 1 showing on dice 1. That means 2, 1. 2 showing on dice 1, and 2 showing on dice 2. 2, 2. 2 showing on dice 1, and 3 showing on dice 2. 2, 3, and so on. So that is give us the possibilities that we have for this kind of scenario, so that we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So 36 possible outcomes for 2 dice. Remember, for 1 dice, it's only 6 possibilities. But when it's 2 dice, it's have 36 possible outcomes. Okay. Any question? Good. Excellent. Now, so question 2 say, find the sample space for drawing 1 card from a deck. Well, the sample space is here. 52 cards. If you count them, there are how many cards in this? The ace has club have 13 cards, diamond has 13 cards, hearts have 13 cards, and then we have spade 13 cards. So that we have club is 13. 13, can count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we have that. Diamond is 13. Okay, hearts 13. Spade 13. So that sample space will now become, you add all of them, the possibilities. So the sample space becomes 13 plus 13 plus 13 plus 13, which is 52 cards. You got 52 cards, sample space for deck of cards, 52 cards. 2 cards is the sample space. So at this point, we are ready to look at an example. It says the equation goes this way. Example on classical probabilities. So the equation goes this way. It says a card is drawn from an ordinary deck of 52 cards. Find these probabilities of getting a jack, of getting a 6 of clubs, okay, of getting a 6 or a 3. Now let's get the sample space first. For a card, we know that it is 52 cards. 52 cards. I'll make this a little bit bigger. Make it 60, 20 maybe, or 18. Okay. Sample space 52 cards. So the probability of getting a jack. Okay, how many jack we have here? We have jack 1, 2, 3, 4. Okay, 4 out of 52 cards. And that will give us 4 over 52. Okay. And then we can now go to our calculator and get 4 over 52. Okay, 4 divided by 52 cards. 0.0769, that we round it to 3 decimal places, 0.077, 0.077, 0.077, or we can call it, if you like, 7.7%. Okay, these are the ways we write probability. The second question is this. It says, of getting 6 of clubs, getting 6 of clubs. How many 6 of clubs we have? We have, under the club, we have only one of them that have number 6. See? So one club has number 6. So that getting 6 of club is 1 out of 52 cards. Okay. 1 out of 52 cards. Which is, we go to our calculator, 1 divided by 52 cards, 0.019, rounded, 0.019, okay, 0.019 equal 0.019, or if you like, you can call it 1.9%. Okay. Okay. Now, part C says of getting a 6 or a 3. See, getting a 6 or a 3. How many cards have number 6 or 3? There are a 6 have. There are 4 cards of. See, this is number 6. How many cards have that? 1, 2, 3, 4. 4 cards have number 6. 3 is number 3. 1, 2, 3. 4 cards also have number 3. So the probability of getting a 6 of card is the probability of getting a 6 or a 3 is the probability of getting a 6 plus the probability of getting a 3. Okay. For 6, we have seen that there's 4 cards that have number 6 on them. 1, 2, 3, 4. And 4 cards that have number 3 on them. 1, 2, 3, 4. So that the probability of getting a 6 or a 3 is 4 over 52 for 6 plus 4 over 52 for 3. And that will give you the answer you're looking for. So let's do it. We go to our calculator. We have 4 over 52, okay, plus 4 over 52. 52. Okay. The answer becomes 0.1538. It continues. So we round it to 0.154. 0.154. Okay. 0.154. Or if you like, you can call it 15.4%. Okay, I'll call it R 15.4%. Any questions?
No.
Good, good, good. So now we have only 3 minutes left now. So you will not be able to do much in 3 minutes. So what I'm gonna do is I'm going to time us out. I'm gonna time it out. So when I do that, wait for 10 minutes. 10 minutes, then log back in using the same link that you used to log in tonight. So, wait for 10 minutes when it times out and log back in using the same link. So I see you back here in 10 minutes. Okay? All right.
Okay.
All right.